I'm so nervous. The reason I'm saying I'm so nervous because I feel like actually put a step in there and change. I think that I'll have to change. Just like this game is perfect. The thing is fun, but what it's about is combination stepping in. Like that's when I would change all this. Exactly.
Morning.
Morning.
How you guys doing? Yeah. Did you make it through assignment one?
Yeah.
You just not answer that one.
Yeah. Better not to answer. I haven't graded it yet, so I don't know if you actually made it through or not. So you can lie to me right now and say you awesome or terrible. Or we don't really know until I grade it. Anyone have any questions? Anyone look on Canvas and see what's upcoming in the next couple weeks?
Lab 8 and Lab 9.
Lab 8 and Lab 9 today. Lab 8 we'll work on today, Lab 9, right? On Wednesday. Next week we'll do Lab 10. And then what are we gonna do next Wednesday? Let's see.
Midterm coming on?
Yeah, midterm. So midterm number 1 is gonna be next Wednesday. I'll talk about it more on this Wednesday. But I put a little study guide, which is really just like, this is what we learned, right? Look at the lectures of what we learned. That's up on Canvas. It'll be a combination of, we'll do some multiple choice via Canvas, kind of their quizzes stuff. And then we'll also kind of do a lab in a sense. So you'll have a coding portion where you'll do it on the computer. The only difference is you won't be able to ask your neighbor for help. You won't really be able to ask me for help. So that's kind of the difference. So it's like a lab, but it's not going to be even nearly as hard as what a lab might be.
So it's not fast.
It is. It's coding test.
But it's not like,
You're like, I don't have to solve for X or anything like that. Right.
so you won't like, give us like multiple choice, which.
No, there'll be a small multiple choice part that's online. But weight wise, it's like a quarter of the points. 3/4 will be writing. Huh? It's on the computer. But no Google. Right. So your feedback you get is from your compiler, right? You're gonna compile it and it'll hopefully tell you where your syntax errors are and all that kind of stuff.
And program algorithms one let us use like a sort of like a cheat sheet where.
Yeah, so you can have your cheat sheet, so that's your Google. You can take an index card and write whatever you want on both sides. So, and I'll mention that
I'm
on.
taking advantage of that again.
I'll mention that on Wednesday as well. So yeah, you can write.
The index card starts?
Yeah, like index card, which is like a little.
What if I write
Yeah, no,
really
not
slow?
poster board, no infographs or anything like that. I might have one.
Maybe that would take mine. Let's see your shit.
Teachers in the past have to do.
I just do things about it.
Right. I know it's smaller than this. So. I don't know. Bigger than a playing
It's
card.
a 3x5 or something.
Yeah, they call them 3x5 cards, but they're not actually 3 inches by 5 inches, or 3 feet by 5 feet.
3 feet by 5
They're
feet.
small, and they need to be handwritten. Don't be making things in tiny font and handwritten. Or I use it as a study tool. But if there's syntax that you're like today, you're like, I don't want to remember how to do command line argument syntax. Just write it on the card. Right? Keep your brain space for something else that you really want to remember. Does that make sense? We have other questions about that or anything else?
They put a link on the card, can I use?
Yeah, the link, click the link. Yeah, cool watch that, like, we'll do a holographic display in front of you. You could do that, right?
Hey, good luck with that.
That sounds kind of fun. But yeah, just basic stuff. Right, I think the big thing is that when you do that coding portion, right, you won't be getting help from other people or from me, really. People ask, and then I come over and I'm their code, and then I'm like, I can't tell you what the answer is. I'll come over and just look at it if you want. I can't tell you anything.
Go up to the computer. Yeah, that's code.
Yeah, it's code. Yeah, good job or not good job. I can't really tell you if you're doing well or not. Exactly. Yeah, I can give you a pat on the back if that's what you like. That's fine. Right?
That's a keyboard.
If you already wear glasses, you can wear glasses for your 3x5 note cards. I don't normally wear glasses in my class and you bring big old thick ones to look at your tiny font. You can't do that.
No magnifying glass.
Bristle's pretty good. You got your little.
Yeah. People come in like, what are you doing? It's like, no, it's
Spend your whole test reading your note card.
I'm like, yeah.
Other questions? So we're gonna do 2 very distinct things today. One of them, we're gonna look at command line arguments, which I think conceptually should be pretty easy. That's really what your lab's on today. And then we're gonna start getting into object-oriented type stuff. So we're gonna talk about structures and class syntax and kind of just refresh or start anew what these things look like. And then on Wednesday and next Monday, we'll build on that and kind of introduce all of the class type syntax that we need, which is important. We're going to write classes a lot this semester, so seeing how that works and how objects get created from it is going to be a big, important concept for us. Sound good? We handle this? All right, we're going to do all this. All right? This is my big thought for the day, right? When you create a program, you get an executable, right? Remember we did a whole lecture about like G++ and how it compiles stuff and the preprocessor does stuff. But basically, right, in a compile type language, what C++ is, write code, we hit compile, it packages everything up together, and you actually get an executable, right? For us, that executable, because we type make, right? Someone named like lab 1 or lab 7, right? Or assignment 1. Right, that's what we run, right? / whatever, right? We run that executable that's been needed. right? And this semester we're running from the command line. Almost all of you are actually doing that. Some of you are still holding out hope that, right, you're using your IDE of choice and you're like, we'll just copy stuff and make it happen. Right? But overall we've been doing, right, all my lectures have been from the command line, right? And then if you think about programs a lot of times take input, right? And how they get that input can vary, but they take input, right, from users, files, all that kind of stuff. Right? Does that make sense? We've done a lot of lectures on input as well. Right? It's all sorts of places. So here's a program that gets a file from a user, or a file name from the user, right? And so the whole program is made up of what? The user sees this, and then what happens? On this line, what happens? Takes their input, right? And between those two things, what's happening in the program?
String is created.
So yeah, behind the scenes, right, we have this storage space. But from the time the user sees that, to the time the program continues, right, the program's just sitting there blinking at them, right? So the program really pauses and waits for input. Everyone good with that idea? Right, so that's kind of what's happening. So we're going to look at some problems with the approach of this kind of like back and forth of like, here, you need to give me something. Oh, yep, here it is. Okay, here, give me something else. Wait. All right, take it, that kind of stuff. And the big problem is there's no real way to automate it, meaning that if your program takes interactions from the user, then the user needs to be at the program the whole time waiting for them to type something in to continue the program. Otherwise, the program just hangs and sits and waits. All right, which is what that. So in that example, right, we're waiting for a file name. And so command line arguments are a way for us to kind of automate a lot of things and basically get input into the program all at once when the program starts. All right, command line arguments because we write them on the what? Command line. And when you hear arguments, what do you think? Pass, right? We're passing into functions, right? So arguments get passed into functions. Okay, but we're passing in arguments from the command line. So what function do you think we're going to pass them into? Main, because that's where our program starts. And so we're going to learn today how to add parameters to main. And those parameters are placeholders for arguments that get passed in from the command line. Which is actually pretty cool. All right, so let's look at that. And we've actually already used command line arguments, like in your assignment. Remember you said make, but then you had to say make space unit underscore test, right, to make it. So make is the program, that's the executable. Unit test was one of the command line arguments. So they're optional, which is why we haven't seen them yet. All right. So you can do things like this, right? This would run my program, and then we can do things like this, and that would be one command line argument passed into my program. But really, we're going to find out that that's actually two command line arguments, where the actual program is the first command line argument, and then myfile.txt is the second one. And you can have lots, right? And you'll notice that all of your command line arguments are separated by what?
Space.
Spaces, right? So space is the separation. So really you're saying, here's a program, and here's arguments that I want to pass into that program, right? Building off our example, right? Instead of asking the user for the file name in the program, right? Program starts, hey, can you please give me a file name? This says, hey, run the program and start it with these things, right? So I'm not going to stop at the beginning of the program and wait for you to give me a file name. You've already given me a file name because you did it on the command. So a different form of main has argc and argv, right? And by convention, we write it like this. So instead of normally it's just int main, open close paren. Now it's int main, int argc, comma, char star argv, square brackets. I'm going to talk about what both of those things are. But think of it basically as argument count, argc, argument count, how many command line arguments you have. And then think of argv as command line variables, argument variables. And so it's an array of characters, and really it's an array of strings is how we're going to treat it, right? Saying what, right, each command line argument is. So there's two ways to write it. We use the first form to remind us really that it's an array. Because when we see square brackets, we think of what?
Array.
Arrays. Okay, so think of it as an array of strings, even though it says char star. So argc, once again, just tells us how many arguments they are, right? So it's argument count, right? It's always size 1 because the name of your program is a command line argument. So when we say /mod5, ./lat5 is an argument. Okay, so you always have one, but the useful arguments always start at number 2, right? Because 1's always the name of the program. Not so useful. Right? Args, where they're stored, it's technically an array of C-style strings. C-style strings are arrays of characters. All right, and this is actually an array of characters. But I want us to think of it as an array of strings. Okay? Where each element of the array is a string, and that string is, right, the name of the command line argument. Right, so it's char star argv square bracket. So I'm going to show you how with an argument count, knowing how big the array is, and with an array, how you could maybe do some stuff with that. And so let's look at that example. So it's built in, but we want to just give, right, some more parameters. So int argc. Does it have to be named argc?
No?
No, right, because the parameters, you can name them whatever you want, but by convention, right, this is how we name them. So once again, argc is your argument count, right, argv is your, right, array of arguments. So we're going to say if argc equals 1, right, there's only one argument. And then the else would be there's at least, right, more than one. Because we said there's always one argument, right? And that argument is the what? The name of the program, right? The name of the executable, right? So there's either going to be one or more than one. So we're going to do a loop. If I equals 0, I less than argc, right? Because argc tells me how many we have. Right, we want to go to each one, so we're going to do I++. And then we're going to output our index, a space, and argv at that location. Once again, treating it like an array. Right? If there's one thing, right, I only have one thing. Otherwise, if there's more than one thing, let's loop through each of those things. Tell me where in the array they're located, right, which index they're located, and then tell me what they actually are. So let's see what happens. G++, main.cpp. You're going to say, even when I do G++ main.cpp, G++ is the executable, right? That's the program. So main.cpp is a what? It's an argument, right? And so you can pass in multiple things into G++, right? All these command line arguments can get passed in. So you can G++ more than one CPP file at a time, right? All these command line arguments. It's not like you run G++ or make and it says, right, program starts and it says, welcome to the program. Can you please tell me the file names that you would like to compile, right? And then you write them. You just write it on the command line, right? And then it'll just get what we want. So now we can do ./a.out. Right? And it says what? There's only what? One argument, right? I can instead do hello world. How are you? Right? You know, so when I run my program, like each individual word, and not really word, but each thing separated by white space, right, is its own command line argument. So we're going to index what? 0, because it's an array. But the first one that's useful for us really is that index 1. Okay. We always break these rules. We always say arrays always start at 0. Always start your loops at 0 because arrays start at 0. Command line arguments, though, really always start your loops at 1 because the first thing that is useful for us starts at location what? 1. But do not, and people keep making this mistake, do not go less than or equal to size. Just go always what? Less than size, right? Don't go less than or equal to size. Go less than size. Less than equals too far. Right? Your arrays of size 5, your indices are 0 through what? 4. So when you go to spot 5, you're somewhere else where you're not supposed to be. So not less than or equal, but just less than. Questions on basic command line arguments? Big thing is what? Putting the arg C and the arg B in the parent.
What's the star for?
It's a pointer. That's all I'm gonna say about that.
Yeah, let's go ahead.
After the test, we're gonna start a whole unit on pointers, which will be fun.
Somebody.
Not fun for you. It's fun to teach. For me, I gotta draw on the board and do all sorts of fun stuff. And then watch you struggle as you accidentally go to the wrong place and your program crashes over and over and over again. Remember, I'm gonna give you the power to crash your program, right? That's gonna happen after the first test. So we'll get there. That's not multiplication, it's a pointer. And really, it's just an array of arrays. So it's an array of arrays of characters. So that's how it works out. All right, what assumption did I make in that example? Right? I guess I didn't make an assumption, but I had a simple if check, right? And so when we take command line arguments, if your program is going to rely on them, we're going to want some error handling to make sure that we know, right, how many arguments I have, is it enough, or that kind of stuff. And normally I just do it by a simple if statement, right? If the argument count is less than or equal to how many I need, then I don't have enough, okay? Why is it less than or equal? Anyone know? Has to do with what? Where the first argument, right, is the file name, right? Meaning if I want 4 command line arguments, really I'm going to get 5 because the program is going to be 1, right? So less than or equal says I don't have enough. So if I want 4 and they gave me 4, well, one of them's the file name, so they only gave me what? 3, right? So we want it to be less than or equal on error, or the other way we would write it is what? Greater than the required number, right? And that would be everything's okay. Now, arguments come in as strings, right? Remember, because we type them on the command line, they come in as strings, right? But those arguments could be, right, integers, doubles, right? Single characters, right? They could be, but they always come in as what? As strings. You remember lab 4? Yeah, no, I don't remember any of those labs. There was a lab where we wrote a bunch of functions, right? Converting strings to ints, strings to doubles, strings to characters, right? And so you want to maybe use those functions to take the strings and then convert them to what you want them to be. Does that make sense? But they all come in as strings, so you can't take the argument and multiply it by 10. It's not going to work, because it's a what? String. So we need to convert them to what we want them to be. So let's look at, right, just a little bit more with our example. So I'm going to bring in, right, you did this in the lab, right, a while ago, and now I'm just going to give it to you here. So a function called string to char. All right, let's look at what it looks like. Right. Notice string to char takes in a string as an argument, and it returns a what? A character. All right. Converting strings to characters is not hard because if we're looking for a single character, we just check the length and make sure the length is 1. That's what it says. If value.length is 1, we return value at 0, right? If there's 1 character in the string, I'm going to return that character, converted to, right, a character from the string. And if not, I'm going to return the null character. Right. Anyone know how I can make this function better? Maybe not better, but make it look a little bit nicer. Nobody? Nobody knows?
You can put brackets on the end of else, right?
I could put brackets, but even better,
You take it out?
I can actually just get rid of that. And obviously indentation, right, makes it look nice.
Yeah.
So it could be just a 3-liner, right? If, right, the length of my string is 1, then it's a single character, so return that single character. What happens on a return statement? What happens to your function? It ends, right? It's over. Right? So if it gets to line 35, will it ever get to line 36? No. So do I need an else? No, right? Now, if the if is false, it will skip over line 35 and go to line what? 36, which is a return statement. What has a function? Okay. So in functions, if you end early, right? Basically, that's an end early, right? That if statement says, I want to end the function now, not when it actually is supposed to end, right? So if you end early, you don't have to put the rest of your code in an else statement. Because the only way to get to your rest of the code is if that if statement was
False.
false. That make sense? The other way I could have made it look a little bit nicer, and this has nothing to do with anything besides, right? Length is 6 characters, and size is only 4 characters. So, if you're lazy, right, you don't want to use extra characters. But no, if you have one thing on the if, you don't need curlies. I like to put curlies on because I just think that it helps say, right? Helps you read it a little bit. But the curly braces aren't needed.
One line under the if is the same as having curly braces.
Yes.
On one line.
But don't make the mistake that 2 lines under an if they're indented doesn't mean that's not going. So now I have a simple one, right, to check to make sure that my arguments are a little happy with the deleting. Right? So I have a function that will theoretically change strings to characters. So I'm going to get strings in as command line arguments, and at some point I'm going to want to convert them. So now I have a function that would allow me to do that. So let's do a couple things. I want to create a variable called output. I want to create a character called single. Right? And then we're going to do a simple check. If argc is greater than 1. What do you think that if statement is really saying?
Is there anything other than my
Right. Is there anything other than my file name, right? My program name? Meaning, basically, there are command line arguments. So this was the opposite, right? In the slides, I gave you the error, right? If argc is less than or equal to the argument count. Here, it's just basically saying, right? If I have at least 1, then I'm good. Right? And so I could add an else in here. Yeah, I didn't have enough. Yeah. Not enough arguments. So you return 1, right? Return some other error saying, well, the program did not work as expected. But if my argument count is well, right, then I want to do some stuff. Let's do some stuff. What am I going to start I at? I equals what? 1, because 0 is the file name. So I equals 1, I less than argument count. All right, let's increment it by 1, so I'm going to go to each one. All right, I'm going to write this without talking, and then I'll explain. But what I really want to talk about, right, is the if statement. So the for loop is going to loop through my array of command line arguments. Everyone good with that idea? Right? So it's going to loop through this array of command line arguments, right, from 1 to however many I have. Notice it's not less than or equal, it's what? Less than. Okay? Let's talk about that ugly line on the if statement, right, which I'm trying to do too much, but I want to show you that it works. Okay? So why does it look weird? Like, why does it look weird to you? What am I doing? Not even like, right, just structurally, what's happening? So I'm doing an assignment operation, right? Is everyone good with that? Doing an assignment operation. What else am I doing? Right? And also, is it equivalent to the null character? So I'm doing 2 different operations that usually shouldn't be done on the same line. right? We normally do a assignment statement or a comparison. Does that make sense? You notice that I'm in an if statement, so really I'm expecting that everything in the parens is going to be either what?
True or false?
True or false, right? So I'm expecting that whole expression to evaluate to either true or false. Which one do you think has higher precedence? Assignment operation or the equality operation?
Equality.
Equality. Why do you think equality has a higher precedence?
It has to check if it's null, right?
Like, because it has to work, right? You must have written it in a certain way. But if you think about it, what do we use the assignment operation for? Put things into variables, right? X equals what? 5 plus 3. Right? Everyone good? The 5 plus 3 has to happen first. Right? Because basically you have to get everything down to a single value and then assign it. So the assignment operator actually has a really low precedence. Okay? Because of that idea that it needs to be right down at the end. But in this example, right, even though it has a lower precedence, what do I have? An open paren and a what? Closed paren. And you always do the things in the parens first. Am I good with that idea? Right? And so the first thing that I'm going to do is I'm going to take, right, my command line argument and put it into my string to care function. Right? So this is the first thing that happens, the thing to the right of the assignment operation. So I call this string to care, and it's going to pass in my argument to my string to care function. What does my string to care function do?
Checks to see if it's a character.
Checks to see if it's a single character or not, right? And if it is, it returns that single character. And if it's not, right, what does it return?
No.
Null character. Which means that single will either be the null character or any other single character. Is everyone good with that idea? Right? Single will be either a single null character or it will be any other single character. Because string to care said, you can give me any string and I will give you either a single character or I will give you the what? The null character. And so single gets assigned some character. Are we good with that idea? Okay, what's the next thing that's going to happen? So that's everything in those parens becomes single, right? Whatever that single character is going to be. What am I going to do with that single character?
Compare it to null.
I'm going to compare it to the what? The null character. And if it is the null character, I say at least one of your arguments is not a single character, and I exit my program. Why? Like, I don't know what your program does, right? But I wanted to make sure that all my command line arguments were what? Single characters. And so I'm assigning it because it's going to be a character, and then I'm making sure that it's not the null character, right? So go through each command line argument and make sure that they are indeed individual characters. If it is a character, append is a function for strings that just lets you add on a character to a string. So I'm going to add how many characters? One. What character am I going to add? Single. All right, so I'm going to add a character to the end of my string. Has anyone figured out what the program does? Okay, so it takes command line arguments, and for each command line argument, it converts it to a what? A character. And then what does it do with that character?
Adds it to the end of the string.
Adds it to the end of the string. So it's going to take each command line argument, make sure they're single characters, and it's going to build a string from all of those command line arguments. I don't know why you are programming.
I guess.
That's what's gonna. I just asked you what it's gonna do. I don't need commentary of whether you like it or not.
I'll put a regular string, but okay.
Right.
What's the opposite of append?
Remove.
Yeah. Right. I'm gonna get out of my loop. So there's my loop, but still in my if statement. I'm gonna see out the thing that I made. All right, and now I want to go see my creation. So let's look at it.
Oh.
Oh, what did I do?
String.
You know what I did?
String was not declared.
No using statement for strings.
Yep.
It's always so fun when you get like a really long error message like that, and it's just that. Right? That's all I was missing. All that junk was because I forgot to say what a string was. And since my whole program depended on a string, that was kind of a big deal. So I'm going to run it. ./a.out. I can type. There we go. What does it say? Not enough arguments, right? Which is good because I had an if statement that said, right, if argc is greater than 1, right? Otherwise, it's an if. In this case, it was just 1. All right, I can do this. I can say hello world. All right. And it says at least one of my arguments is not a single character, which is true because hello is not a single character, right? It's a bunch of characters. But I can do this. Right? HELLO. Give it a space. WORLD. And that's my output of what?
Hello world.
Hello world. Right? So look at each command line argument starting at argument 1. So a.out is argument 0. H is at location 1. So it took each thing at each location, right? Made sure it was a character, and in fact converted it from a string, because each command line argument is technically a string, to a character. And took that character and added it to another string, one single string. Right? And after it got done making all that, it said what?
Hello world.
Why was backslash
Backslash space
space?
is a space. Think about like escape characters.
Okay.
That we have from the command line too. Remember, spaces separate stuff, so it wouldn't pick it up out of the space. But I did hello world, and then
Without the slash, it wouldn't have a space.
if I said hello world and not, right, I'm going to get at least one of my arguments is not single. It actually made a string hello space world, and then the next command line argument was not a character, and we said just crash the program. So it did a lot of work, and then at the end said, oh, sorry, you finally gave me something that I didn't like. Try. That's good. Questions on command line arguments? Is this the point where I say that I've given you everything you need for your lab, but I'm still going to talk for like a while longer? If I say that, will you still listen to me? Or will you start hitting your lab?
Sure.
Something. Okay, we're going to start into object-oriented programming, and we're going to start that by first looking at the idea of a structure and how structures in C++ allow us to group data of different types. Meaning right now I can create any variable, but it's going to be an integer, which holds how many integers? 1. Or a double, which holds how many doubles?
1.
1. Or a string, which holds how many strings?
1.
1. If I want a lot of the same, I can create a what? An array, right? A bunch of strings, a bunch of characters, a bunch of doubles. Okay? Structures allow us to create variables, right, that can be both integers and doubles. And strings, right? So this kind of compound variable, if you want to think of it in that way. Right? And we do this because things have, right? We're going to look at things kind of like objects, hence the reason we're going to talk about object-oriented programming. But things have attributes associated with them, and some of those attributes, data-wise, can be stored as integers, but some of them have to be stored as doubles, some of them have to be stored as strings. So if we think of a car, right, car has distinct kind of data associated with it, right, like the year it was made, right, how many doors it has, right? You notice that I put types on most of these, right? Years should be integers. I don't think cars get made in like 2010, 25, right? You don't have a half a door. It may feel like your car has a half a door, right? But you don't actually have half a door.
I actually have 0.9 of a door.
Right, exactly. Missing just a little piece of it. Right, exactly. Right? If you got a Jeep, you just take your door off, right? You have no doors. Right? Horsepower, right? How much horsepower you have, that could be expressed as a double, right? And then like the make and model of your car would be strings. Does that make sense?
Mm-hmm.
So all this data is data about a car, right? And all cars really have the same data points, right? Those data points.
So a blueprint?
Right,
So
some kind of blueprint for a car, right? You're like, what? We can make cars today? We can if we want. Right? But each of these are different types, so I'm gonna group them all together. If I didn't, it would have to be like car 1 year, car 1 doors, car 1 horsepower, car 1 model, right? 4 different variables. And then if I had another car, it'd be car 2 year, and car 2 doors, and car 2 horsepower, and car 2 model. Does that make sense? Because those data points are all related to a car, but if I can't group them, I have to create individual variables for each of those things. And so that's where structures come in to allow us to group things together. Right, so I kind of want to group everything together. Right, I want a single car that has its years, its doors, its horsepower, and its model.
Aren't these the same slides from Programming and Algorithms 1?
Similar.
Yeah.
It's the same stupid car. Right? It's just rearranged a little bit. So syntactically for a structure, okay, we have to create a blueprint of what the thing looks like. Okay, so that's a 2-part process. Right? You're basically defining what they look like before you actually create them. Okay? We don't have to do this for integers because we already know what integers look like. We don't have to do this for doubles because we know what doubles look like. But C++ has no idea what a car or an auto looks like. And so we want to create, right, placeholders. I'm not going to call them variables because these aren't technically variables. Right? They're placeholders for what cars look like. So we're basically saying that autos are made up of years, doors, horsepower, and model, and I have types, right, associated with them. I can add more, right? I can add arrays if I really want to, right? I can add anything in there that I know how to create data-wise, okay? Meaning you're not going to put if statements inside of here, right? Structures are all about data. What data could possibly be associated with an auto, and how do I want it to look? Questions there? Right, so we have a keyword struct, you see that, that's there, right? Auto is any name that you want, right? But auto is going to become a type. Just like we have ints and doubles, auto is now a type that allows us to create variables. So you can name it whatever you want. In this class, it should have a capital, it should start with a capital.
What's the difference between a class and a structure?
We're gonna get there. So I'm not gonna answer it yet. But it's a great question. Structures bodies, curly braces, and then it has the weird semicolon at the end. Everyone see that? Don't forget the semicolon at the end, or you get weird error messages. Like every error message is weird, but you get more. All right. These are technically called member names, right? Notice I'm not calling them variables because they aren't variables. You do not put data inside of this structure. You create autos from the structure because it's just a blueprint, and you put your data in those things, right? And you put this definition for the structure above main, so everything else in your program could use it. And then to create a structure variable, you basically just say the type, and then any identifier that you want. Okay? And that makes it become this fancy thing called a what? Not just a variable, but a what? You ever know? It's an object. So we're going to start creating objects. Objects get created from structures and when we get to classes. So if I say auto car, right, that creates me, right, a variable. So I get a variable named car. Right, variables I always draw as boxes. Right, let's even take a step back. If I say int x, right, I'm going to create a box called x, whose type is what?
Integer.
Integers. What can I put in that box?
Integers.
Integers. Great.
Yeah.
There's an integer. This, right? Same thing. Type, right? Int, type what? Auto. Name x, name car. So if this is a car, its type is?
Auto.
So I'm going to make my box look the same.
Yeah.
Right? X and int, car and auto. Are we good with that idea? If you have a structure to create an object, it's the same syntax as creating a variable. Name of the type and the identifier, right? The name of the variable. The only difference is this just holds a single integer. Agreed?
Mm-hmm.
Whereas an auto holds what?
More boxes.
4 types.
4 boxes, right? I like it. 4 things. Year, doors, horsepower, and model.
How do we pick specific parts?
We'll get there. We'll get there. And not only that, but each of those have a type associated with them, right? This is an int. This is an int. All right, this is a double. This is a string. And so when we look at structure objects, we can look at them in 2 different ways, okay? And one way of looking at them is the whole, right? And so I'm gonna draw this like box around everything, right? So a car is an auto, okay? And so that red box represents the entire object. But a car also has parts associated with it, right? And the parts of this car structure are what? Year, doors, horsepower, and model. So it is one object, so one variable, but that variable is made up of 4 other variables. Does that make sense? And those 4 other things are, right, basically base building blocks that we already know about, right? So types that we already know about. Are we good so far? All right, and so the question is, how do I get down inside of here? How do I get down inside of here? Remember?
Whatever you want to set.
So we start with our base object, which is car,
Put a dot on it.
and then we put a dot.
Whatever.
The dot is called the member accessor, so it allows us to access members of the object, which means members being year, doors, horsepower, and model. So if I said car.year, right, car.year, right, car is an auto variable. Car.year is of what type?
Int.
Int. It's an int variable. Okay, car.year is an int variable. So I can put into it any integer that is allowed. What year do you guys want your car to be?
2017.
Like, not new enough, but right?
I just
Much newer. Right? Think about the savings you get, right? Let someone else take the hit for a year.
Is there a way to check like in the object you can say the year has to be at least 2000?
Nope.
No?
Not in structures.
Okay.
We get the classes, yes. We get so much more control. Right now, it's just an integer, and they can put in anything in that integer that's allowable for an integer. Alright. So now my car is 2017. How much horsepower do you want your car to have?
350.
Right? So then I would say car dot horsepower, right? Equals 350.
It's a powerful car.
Car dot horsepower is what? It's a double, right? You just get to it via the name of your variable, car, the dot operator, and then the name of whatever, right, data point, whatever member name you want to access. Does this make sense a little bit? Right? The nice thing is, though, once you have a blueprint for cars, how many cars can you make?
As many as you want.
As many as you want. Right? It's basically asking the question, right? How many integers can you make in your program?
As many as you want.
As many as you want. Right? So I can make as many autos as I want. So if I want
Practically 4.
auto horse, right? We can make horse, right?
Horse would have 1 horsepower.
1 horsepower, you got it, right?
Actually, my horses really has an 18 horsepower.
Does it?
It's full sprint.
Full sprint. I like that.
Model T.
Right, what weird units of measure we use in America. That's for sure.
Because 1 horsepower is only when it's like walking and pulling like a weird
Okay.
two.
But it has to be the right, like weight, right?
Yeah,
And
so
Complicated.
so you're saying I probably have 1 horsepower?
No, Luke, you have half a
Maybe 1
horsepower.
horsepower.
Maybe not built.
Fresh, right? What? I don't want to know. With the wind on my back down a hill.
Oh, God.
Questions on structure so far? Because now I have no idea where we are.
I want more control.
We'll get more control. So we did all that. Yay. All right, dot operator, right? You can use it. We only did assignment, but obviously you can use it, right? Car dot horsepower is a double, so you can use it anywhere you use a double. Meaning you can use it for output. You can use it as an argument to pass into a function, right? You can use it anywhere you would use a regular variable.
what's the difference between the dot operator and the
Colon is for defining. So it's the scope resolution operator. So it's for defining what structures and classes look like. The dot operator is when I have an object from that thing. So one's used with blueprints and one's used with actual implementation. I think we did that, right? It could be a collection of member, right, values, or it can be the whole complex thing. So you can actually do this, right? If you have a cooler car than me, I can say my car now is assigned your car. Right now we both have the same car.
Oh.
They're copies, I'm not stealing it, they're copies. Right? But this should make sense because if I had two integers, can I say int 1 equals int 2? Sure. Right? So in the same way you can say car 1 equals car 2.
If they have the same blueprint, they can be assigned to the same thing,
Yes,
right?
right.
So
So
if I had a different object and tried to assign it, it would freak out.
Yes.
Okay.
You can't put houses in the cars or cars in the houses. All right, should we create a structure? This is the feedback part. We say yes. Create a structure. All right, structure start with what keyword? Struct. That's so nice. We didn't need the RE, right? Or the URE. So struct car, right? Year, doors, horsepower, make, and model. Notice that where did I put it?
Before main.
Before main, right? We can keep our command line arguments, right? Main in there if that's what we want. But I can do some stuff like this. I'm gonna paste it in because you don't want to watch me type this all, but we'll talk about it.
Oh.
So how many cars am I gonna create? 2, right? Line 19. So both, right, my car and your car are variables called objects that have, right, other data associated with them. So my car and your car both have a year, a doors, a horsepower, a make and model, but they are their own distinct variables, right? So your car.year is different from my car.year. Make sense? All of those values start as what? Garbage. Minus strings. Strings always start as the empty string. So the 2 ints and the double are garbage values. Make and model start as the empty string. Which is kind of garbage as well, but right, at least right, reproducible garbage. So one way to get data is to just assign it, right? My car.year, my car.doors, my car.horsepower. Are you good with that? Right? The other way, well, another way to get data would be to, right, use a CN statement. So then, right, ask, what's the year, right? Get from the user, store it into a variable called your car.year. Your car.year is an integer, right? So it's expecting the user to type in an integer. Oh, we're gonna lose it. Does that make sense a little bit? Right? So I was gonna get everything. I want you to look at this one real quick while I get my power out, and then we'll talk about it. Is that input or output?
Output.
Output, right? And what's all the weird stuff that's happening there?
You're creating white space?
Just formatting, right? So we talked about that last class, right? We use .width to format our output, right? And so we're saying no matter what we get from the user, we're going to say it's at least 15 characters wide. So when we output the make, right, it's all going to be set at 15 characters wide. So we're going to hopefully uniformly, right, make it look kind of nice.
This will populate some right below.
Yes.
Like it'll spell that.
No, it won't spell actually. That would be. We can write programs that will spell backwards. Oh, I should probably make it again. Huh?
Oops.
Should I save it? Probably not. Let's save it. Save is important. Oh, no, say W. So we just go up. That W, which is actually in item and init. So bring that library in. Good. What is the year of your car? What's the year of your guys' car? Anyone give me
1930?
1930. Okay.
Like, you got a whole car.
Right. How many doors does it have?
8. 8.
It could be 0, it could be open, right? It's not a door, you just jump in wherever. Right? Unfortunately.
1,500.
I don't think there were any 1,500 horsepower cars in
Volkswagen? Golf?
There you go.
Yeah, there we go.
There's my car in your car. Not so sure how accurate these are.
It's a powerful Golf.
Powerful golf.
Some gold.
Jeez. Jeez, I mean, just imagine if they made that today. It'd be like 3 million horsepower.
You could get to the moon, to Mars with that car.
Exactly.
Just find a hill and drive down this.
Just press on the gas, I'm already halfway across the planet.
That's like who's trying to make you get anywhere in the world in like 8 months or something like that.
I think it's like a light speed railway or something.
Wasn't it that underground?
Well, he's doing the boring stuff too. He's got all this stuff. But no, they want to like shoot you up in a rocket, and by the time you go up and come back down, like it's not for like 15 minutes, like anywhere in the world or something like that. No, probably not.
Sounds really inexpensive.
Really expensive.
Super
I think
common.
some people have extra cash lying around.
Hey, when you're a millionaire, you don't want to wait on that plane for 8 hours.
No, right? I want to get there now. Yeah.
Only for 1,000. Oh, no problem. Might do.
Any questions on structures so far? All right. You can give structures data when you create them. So that's initialization. All right. So here's my structure. It's a date structure, right? Has a month, a day, and a year. And I can give my date structure, right, in curly brace syntax as initialization. So on creation, the month, the day, and the year. That's only on initialization. So not later on, but on creation, you can give it, right, values. And it'll just put 12 in whatever the first member name is, 31, and the second member name in 2013 and the third. Right? So it'll just do it in the order that they're there.
Kind of like an array.
Yeah, exactly. But we have no uniform way of looping through it. That's the big difference. Right. We already said that, right? If you don't fully initialize, so if I just said 1231, then if we go back to my date object or my date structure, year would still be garbage. So month would be 12, day would be 31, and if you leave other stuff off, it would just be garbage, right? Whatever the defaults are going to be. And then you can also have member names that themselves are structures, right? Because when you create a structure, it creates a type. You can now use that type anywhere you can use a type. And if we go back to what my date object or my date structure looks like, right? Ints, these are types, right? These are types built into a structure. So once I have a date type, I can use that in any other structure because date is a type. So I can do something like this, right? We're going to have a person and a date. So date has 3 member names, 3 ints. And then a person has height, weight, and then they also have a birthday.
Let's see.
You notice I was nice, I made weight an integer. Remember, integers truncate. So if you weigh something 0.9 pounds, it's going to truncate down. It's going to make you feel better about yourself. Is that so nice? Aren't I a nice guy sometimes? Right? What's the big thing? We have a structure that inside of it has a member name that is itself a what? A structure. Which is fine. Right? Now we're getting complex or compound structure.
You have to put date left above person.
Yes. So date would have to become first in the code. That way person info would know what a date was. Yeah, so there's an order for that. And then you create a person structure the normal way in code. I don't want to know how you create people other ones, but in code you create that person structure the normal. Person info, person 1, right? But then you need another dot because person 1 has a member name named birthday, but birthday itself is, right, a date, which means it's made up of a month, day, and a year. So I use another dot to access, right, farther down. Each time I go down a level, I use the dot. Right? Make sense? Question?
How would I handle that for birthday if you were to initialize that? Like,
You would do it a second set of curlies. So it's, you want to do it? We can do it. So here I just have those structures, right? A date structure and a person info. Here's today. I didn't know that's today.
That was a while ago.
1900. Right? Our VW Golf has 30 years until it gets invented. Right? It's 1,500 horsepower. Notice that person.birthday can be assigned today, because person.birthday is a date type, and today is an object of date type. Then Sean was asking, what if I wanted to do something like this? I do person info person, and I could say that curly brace could be 6, 175, right? And then you could do another set of curlies. 1, 1900. And so that would allow me to initialize the person, but because the person is made up of another date object, that would initialize the date. So we just add more curlies together also. And so structures are great for grouping what I'm going to call attributes, right? Attributes of an object together. So attributes of a person are height, weight, their birthday, right? And so we create a structure to encapsulate, right? Grab all of those attributes, right? And I can create as many people as I want. Does that make sense a little bit? Okay. We're going to talk ever so quickly about class syntax. And then really on Wednesday, we're really going to get into where I would use class syntax and a lot of the ideas behind it. I just want to throw the class syntax out there for us. So classes, just like structures, have attributes, meaning they hold data. But the big thing that classes have that structures don't have is they also have functions. All right? And these functions allow us to act on things in the object themselves. All right, so we were talking about the fact that, right, car.year could be any year. Right? There's nothing that prevents the user from saying that my car was made in, 1100. Right? Where we know there were no cars in 1100. Right? So one of the things that classes allow us to do is they allow us to write functions that will allow to check to make sure that my data is correct. So I can make sure that the user gives me values that make sense for a car. And I don't get garbage values or anything like that. So structures have data, those are attributes. Classes also have data, those are attributes. But then classes also have functions, and we call those behaviors. Right? So those are like the actions of an object. What can the object do? And we'll kind of break that down here on Wednesday and kind of look at what that looks like. So classes are blueprints for our objects, just like structures are blueprints for objects. The only difference is one only has attributes, structures, and one has attributes and functions. Those are classes.
Why would you ever use structures then?
Because sometimes you just get a bunch of data grouped together. A lot of times we'll do it like with arrays of structures, where I just need to hold a bunch of data, but I don't really need a lot of oversight over that data. I just need to store this raw data.
So the class requires the oversight.
Yes. And it gives it to you, right? You can't create a class that has no functions and then it'll look just like a structure. So here's a sample class that represents a single day. All right. So you'll notice that instead of saying structure, we say class. It still has the semicolon at the end of my curlies. Right? New word public, which we'll talk about on Wednesday. Right? Here's my member names, month and day. They look the same, although I added underscores at the end, and we'll talk about why we do that. And then notice void output is a function prototype. Right? So we've written function prototypes. You'll notice it's now the function prototypes inside of a class as opposed to anywhere else. And this is just saying, right, what you can see.
Do we declare that function below main?
Above main.
Above main?
Yeah, that way I can use it in main.
So there's, the definition.
Well, the definition is below main, just like
Yeah.
we would use the dot operator to access, just like structures. Right? So day of year today would create main object. If I want to, right, access anything in that object, I would use the dot operator. Right? So I could say today.output if I want to call the function. I could do today.month underscore if I wanted to do that integer, or today.day underscore to that. We also have this word when we're using with classes called instances. So an object is an instance of a class. When you create an object variable from a class, we also sometimes call it an instance. It's an instance of the class. And all I really mean is it's a variable, right? It's a variable. It's just a compound variable. I mean, it has more to it than just holding a single integer, right? Day of year holds two integers, right? Month and day. And it also has one behavior, right? Output associated with it as well. All right, so they become these compound things, which are actually really good. Questions there? So that's just like structurally how we would set up the class. We can go back to it. All right. Structurally, how we would set up the class. On Wednesday, we'll talk about, okay, how do I create this function? What does public mean? We're going to get into all those things and break it down. Your next assignment will not be class-based. I'm going to introduce it here. But your coding portion of your test next week is class-based. So it's not going to be a hard class, right? It'll be a pretty simple class where you have some class with a couple functions or something like that. Questions there? You want to see your assignment? Like, I just finished the assignment. I don't want to talk about the next one. The assignment is also due next Thursday, right? And you have a test next Wednesday. So the sooner you start your assignment, probably the better off you're going to be. Good news about this assignment, well, let's see if I can look it up. It's not a lot of code. So once you understand the concepts of it, you'll find that the amount of code that you write is actually not a lot. My entire code for assignment 1 or assignment 2 is 37 lines of code. You guys catch that? So 37. And that doesn't mean yours needs to be 37, but also means yours shouldn't be like 300, 400, 500 lines of code. Right? This is not a long program when it comes to, how many lines of code. It has to have a lot of logic built into it, but it itself is not that long of a program. Yeah, couple of statements, couple of get lines, and you're pretty much good. So let's talk about assignment 2. All right, the purpose of assignment is to learn something. Right? That's probably the purpose of every assignment I have. So there's a program in Linux, Unix world that's called cat. All right, it's called cat because it's short for concatenate. But basically, cat's a utility that will read a file or multiple files and just spit them out onto the command line. It's built in, so if we, here we are, I can cat our main.cpp, and it actually just spits out all the text to the command line of main.cpp. Make sense? I can cat star.txt, which would be all my txt files, and then it will take all of my txt files and just put them all together and output them. So it's a pretty basic program. It's like a copycat program. It just, whatever you say, it just reads the file, and it outputs it. So conceptually, you should be thinking in your head, FIN, input stream from a file, but you see out. So you take input from a file, but you output to the console, so see out. Cat also allows you to just go into it, and then whatever you type, it just, stop copying me. That makes sense? It just echoes out whatever, right? Not as simple as just a get line, read stuff in, and then a see out output. And this one ends by Control Z, which is the sending of the new line here. In Linux land, Control D. So, if you care about the cat utility, you want to read about it, and you love Wikipedia, that's there for you. All right, but let's talk about the ways you can run new cat. So you're creating, cat is a program that exists, so you're writing a new cat program that's trying to emulate the old cat program. So right? You get to create a program called NewCat. Does that sound cool? Like that. So you can run it a couple different ways. You can run it with no command line arguments, right? And that's the, right, you type something and hit enter and then just spits it back out, okay? And you want to do that until the inline character is sent. Control D on Linux, Unix, and Control Z on Windows. So there's your loop. While you're not at the end of file, it's kind of weird, right? What does it say, cn.eof? And cn isn't a file, right? But you can send the end of file command to it, right? So it's going to take input, and while you're not at the end of input, bless you, right? Then you need to get something and output. Option 2, they give you a single command line argument, which is a file name, right? If the file exists, you'll just read the file and output it. If it doesn't exist, in your program with a status code of 1 and tell the user they did not give you a valid file name.
This doesn't seem that hard.
It's not. I told you, what did I say? 37 lines of code.
Yeah.
Some if statements and then figure out what in the if statements you're supposed to do, right? But I know some of us are not so good with file input, so that's the hard part. Right, and the command line arguments, which we're going to do in today's lab, right, that's also a new part. But it's basically just a couple of if statements and a couple of loops. Right? That's why you only get 2 weeks for it. Last assignment, you got 4 weeks. Or you can give a myriad, so as many file names as you want, right? So long as all the files exist, it will concatenate all of them and output them. If even one file does not exist, there should not be any output to the user except, right, one of the files doesn't exist. So don't start outputting until you know that all of the files actually exist, right, and you can read them. Now I presented 3 options, but if you read my notes, which I always recommend, options 2 and 3 are really the same option, right? Because whether you give one file name or you give many file names, it's the same thing. Does it exist? If it does, right, output it, right? And I recommend 2 loops that are not nested, because you need one loop is to just check to make sure all the files exist. Because right now the only way to check to see if files exist are we open the file, and if it opened correctly, it exists. If it doesn't open, it didn't. So I can loop through all of them, open, yeah, close, open, close, yeah, they all exist. And then I can do the exact same loop, but now when I open them, I can output what I want out. Oh, I lied. Look, this says 35 lines. I just told you 37. Well, I said without comments and extra spaces, so I must have been saying it, right? So commenting is going to make it longer, but when you look at the meat of your code, right, there's not a lot. So if you're writing hundreds of lines of code, right, then you're overthinking.
Anybody ever turned in 30 lines of code?
Maybe.
And it worked?
There may be reasons why the assignment says what it says now. Right? I'm just trying to impress on you that code-wise it's short. Logic-wise, you got to think about how am I going to do it. But when you actually write the code, it's actually really short. So doing some of the logic, the pseudocode beforehand, so you know what you're trying to do, and then start writing. And then I give you a bunch of sample files when you pull it down, when you pull it on the assignment, right, to look at output. Right? How do I know that I did it correctly? Well, run it with cat, and then run it with NewCat, and if your output looks basically the same, then you did it correctly. If the output looks way different from each other, then you did it what? Incorrect. That makes sense? Right, and then that also has one of my favorite test ones. Let's see. I think it's in repos. P2, okay, 19. Assignments 2. Is it 6.txt? No. No. I'm gonna find it. 3.txt, it's in there. Look at those lovely output. 4.txt. No. We'll get there, guys. Don't you worry. Oh yeah, there we go. That's 5.txt. It's an ASCII art to make sure of that. Right? So 1.txt through 6.txt are just sample files with text in them. And so that's just making sure that you're reading it and outputting it correctly. So if your ATST looks all weird, then you're doing it wrong, right? But your program will work for any file, right? It's not gonna just work for 1.txt and 2.txt, right? Don't hard code those in. Remember, the names come in via command line arguments, right? Cat 5.txt, right? So 5.txt is the command line argument. That's the input into your program, right? So you don't have any like cout statements that say, please tell me the files you want me to see, or please tell me which mode you would like to run new cat, right? That's all happening via the command lines. The command line arguments will say, okay, am I supposed to be the copycat mode where you just type something and it spits it back? Am I supposed to output one file? Am I supposed to output multiple files? That's all based on how many command line arguments are given. Does that make sense? So get your lab, is it lab 8? Get your lab 8 done, right? Which will help you with how command line arguments work. And then you have everything you need to complete assignment 2, right? So it's due next Thursday, but you have a test next Wednesday, so I wouldn't wait till forever to start working on it. But you have everything. No other lecture I'm going to give you will help you with NewCat. Right? You have everything you need to do. So the earlier you start on it, run your problems, come find me, we talk about it, right? The better off you're going to be. Good? Great?
Yeah.
Life's good?
No way.
Everyone got real quiet. Like, I told you this class was going to be a lot of work. Didn't I say that at the beginning? Mm-hmm. No.
Last semester.
It's very nice, you know, when you take a class like this, and you take physics, and you take calc.
That's exactly what's
It's such a great life that you're
exactly
living.
don't have a life.
Right? Exactly. School is your life. Congratulations.
Dr. White was like, if you create a program to help you with physics, you are allowed to use it for the whole semester.
Oh, really?
Yeah, you can make something that solves every problem for a year like easy.
Well, there you go. Next week. Like, I'll take it.
You take the test and get it right.
Yeah.
But program.
I can't do it. Those tests don't show me in person.
No, I think physics tests are designed to make you feel like you're dumb. Hey, the highest grade on the test was a 45%. You did great.
That's an A with the curve.
That's right. Tells you why people become engineers. Because engineers, it's like close enough, right? You have all the physics behind it, but you're like, yeah, close enough. We'll just over-engineer it and call it good. Yes.
You said that before the time you would upload to GitHub, right?
Yeah. Get command, get right.
Yeah, but I got your email you sent all those on auto-return ones.
Oh, yeah.
So it just gonna make telling them what's inside the canvas?
No, but like instructions and that kind of stuff was on Canvas.
Oh,
So,
okay.
Canvas was down, right? All the sample lectures and code was on there, so.
Okay.
Those people that were procrastinating late at night on Thursday got reprieve. I'm not saying who those people were, I'm just saying, I know you exist. Someone check to see.
I really want to do like a meme about it. I really want to do that kind of
Yeah, it's really bad work.
my classmates.
Modified. So you might have done it once, but.
It's a trick that you can change.
Sure, you get add assignment one. So you might have uploaded it once, but maybe not done it. So now it's there, right, to be committed, right, which is good. Notice there's not the dot agent like that. So we're all good. Right, get commit, dash in,
It's a little bit different, but it's
R30.
yeah, we're just using like the RC and our, the. Pretty much did the same thing.
Was that code never used?
For every,
Yeah.
for everyone. Oh, you made it.
We're just trying to, just like this.
When you commit, even locally, it does timestamps.
This was the size. See, I installed it, got it that size. You might want to put it unsigned, right? Because it's gonna give you a weird error sign.
Whatever the value is.
The size returns unsigned.
I'm sorry for.
Yeah.
Value that
This is
So it's gonna run
Okay,
through.
so yeah, that looks good.
So everything you do.
Well,
And then you're.
I don't know, this is the one thing that I'm really sure.
no, that is right. What that is what basically, just make it different.
Almost every
File.
Probably, results of range, right? Lower.
You don't have if it's not, then you return false. So if it is good, it just ignores this line entirely and lets it out. So you don't, basically, you don't need to check. It's only one file. You only have to one file when it comes in.
Oh, yeah, you got it.
Well, you only need to check the file once, right? Once that check is good, then you're looking inside the file and see if it matches with it. And if it doesn't match any of those, then you do on error. So basically, if it's not 1, 2, 20, 30, 40, 50, then it's on error.
So this, what I have here wouldn't work.
So this would actually be not.
And if I can get this to work and figure out lab age, but it's essentially doing the same thing.
Yeah, I don't see why that wouldn't work. That would work, yeah.
Good work. Yes. Yeah, the first thing is. Yeah, exactly. You just do it. It has our account. So think of argv as an array of
No, that
strings.
might be under all of them. These are all lowercase.
Oh.
They're all lowercase that way.
See, when I was working on this, I was using a small model in the library.
You will, right? But command line arguments are helpful because on command line we can kind of start our program from the That's the power. So you just here, right? You just there's basically an array of strings, and you just want to look at the string and see if they
I guess one I remember carrying
The only thing I'm gonna run into is it's actually an array of C strings or is it called right? String whatever equals RB. It's pretty.
Yeah, well.
RC is just your loop form, so
That's counter.
I equals 1, I less than
And
RC.
then like.
I need a hand on your lab. You can't do this. argv bracket I equals 10 string.
Because it's a pointer comparing to.
This is a C string, and so it doesn't work well with equality. So my recommendation is, right, to actually say, before that, say string S equals argv at I. Now it's a string, and we know strings work fine. So then your if statement can have S equals. You can also do strcmp, string compare, if you want to do that. That's how you do C string compare.
Yeah.
Right. Please run a string compare. That's and it didn't work before because of pointers, which I told you I want to talk about. I'm not going to talk about that.
Oh. Okay. It's done now.
Anyone not sign in? What? So argc is just an integer that tells you how many moving line are in this hour. So it could be like if you had let's say you had right dot slash a dot out hello world. Right. So that was the command line. You have a variable called argc whose value was 3 because there's 3 command line arguments. And then you have an array called argv, and that array would be each of the commands. So this was the first index 0 would be dot slash a dot out. 1 would be hello, and 2 would be world. The only weird thing about that is that technically dot slash a dot out of itself is an array. And hello is an array. So technically
It's an array of characters.
are their own arrays.
It tells you that you have to run these.
And that doesn't really matter except for the fact that when we do comparisons, if we take that array and we store it into a string, then all of a sudden everything becomes easy. Unless it's a C string, it's an array of characters, which is how we use to have to build strings.
So what's happening is you're comparing an array with a string, and it just says that's not possible.
Yeah, well, actually what happens is that it says this is its own spot in memory.
Yeah.
And then it says that other string is its own spot in memory. Maybe they have the same values, they're in their own locations.
Oh, yeah, because you're comparing a pointer with something else. Yeah.
Always. Okay. So argc will always be the size of your argv array. Which is why I put it back on the board. That's why my loop, why my loop always goes I less than argc. Yeah, I do that. Thought this would be more helpful for you. And then usually, this one starts at 0, but usually you'll start at 1 because 0 is the file name and yeah, okay. I thought that loop would be helpful again. Wait a second. Yeah. It seems close to be characters. Yeah.
So that's what
You mean it's sort of a string. Don't worry about that. Just think that's an erase. That's fun. And again. Are you going to argue too? I know. You have to make that's like this type of class, right? You don't care about your feelings. You care about cold hard facts.
I'll just put my arms up.
They're pretty similar. This would be S, this would be W. And then you're, instead of being this, you know, argc tells you how many, because argc tells you, because B is an array, and so argc tells me how many are now.
Oh, you have to check my size. So I just look through it like size. Is argc not?
No, it's not, because it was on line 12, we made it. You made an unsigned, which you could, then you could.
Well, I mean, I'm giving one.
You're trying to get a weird comparison. Yeah, because it's just an this is just unsigned I. You can, yeah. You do a lot actually, unsigned I.
Well, that's what we do inside, so when you're doing some inside, you can run into that. It makes sense, the size can't be negative, you can't have like a negative size or something.
You're on 9. Well, this is when it's full 6 times. We do get to make a spaceship, but not until it's
I was anxious to make
Oh,
space.
that's right.
I know. Well, I already started this one kind of sort of, I thought I was late on it, yeah, Thursday.
So there you go. That's good. I totally forgot. I should have told you that at the end of the class. Wednesday, during the class, we're gonna make a spaceship.
What?
So, make sure you don't miss. Actually, you're gonna make a spaceship in your lab.
No. Well, that's good, because I was freaking out on Thursday, I'm like, oh my goodness.
I don't understand how this works.
But for now, it's just.
Yeah.
Oh, that's. What the heck did I do?
Yeah.
You know what?
Yeah.
I had a degree at the very end, and it was like.
That's the thing, it's like it's
Oh,
not
really?
instrumentation, the thing is because you don't have enough training yet. They're not outputting anything.
Except precision, you have to have a format.
Oh, so your stream is still, oh no, wait, so yeah, you're just, yeah.
Yeah, it's just doing the first portion.
I don't think it's already easy to do that.
Yeah, no, that's not.
I'm not running that video guys.
I do.
Unless it's returning this form.
You'll see online sometimes too, they'll just throw out. It's black, and actually just lots of different ways of doing the same thing. You never get the right answer online.
Did you run the test?
Yeah, I did. I got it. Oh, I got them all to work.
This is weird. I might not start writing out anything.
Yeah.
But.
You have a loop going? Because it's freaking out. Yeah. Because right now it's not even over. So you're gonna wrap this equation. Okay. So here's your
Still
big declaration. So.
Try using Livestream.
CSCI on the spout so high. Okay, so that. That's the while loop. You're running a while loop?
Schedule like updation or something.
I didn't do that. Yeah. But that's why the program is crashing, because it's.
Tuesday, Thursdays,
It's running a while loop, and where is that?
Block it out on my calendar.
Yeah.
But I'm also in my office.
Let's try removing the while loop.
1:30 to 2:45 today.
Work all the time. It sucks.
Yeah, it is rough.
It's good, but it's important, but. There you go, yeah, the knowledge. Okay, try that.
Yeah. I was just looking at from the coding.
Just look through it, so that there's nothing, if you think about it, big loop, full loop for everything. And there's nothing in the loop, right, it's just
Actually, technically, you feel like better.
I'm thinking about during summer learning how to test code.
But if you do that, you end up doing
It's tough to do it.
lab code.
Sean, do you have a question?
Oh, no, we're just.
There you go. Yeah, because imagine for a while loop just kept going. It just didn't stop.
Oh, it's a good thing. All the commercial uses. It's either the shop or then the rooms.
Oh, yeah.
It's like.
Yeah, ready, I'm sorry.
Teacher at Space 10.
Because it was, it should hold forward.
You type in the whole thing after you math.
That's what feels.
How did you run the?
Yeah, I'm still trying to learn next.
Now, your errors fails, just remember, you start at 0. I think that's 0.
1 out of 7 test.
Pretty much from
Alright, I mean, do you remember objects and classes?
Yeah.
There.
Probably what I do kind of all, probably what I do kind of all the way.
Nice.
I just thought, I also want to say, it's like,
Time taken. So you're in there, I'm gonna delete that.
The very first one, you're comparing your index to not the actual string. So you need, the string you created is S, and it's equivalent to your
I'm at town on Tuesday.
index is just, it's just your digit, right? It's just, it starts with one, and then you're taking it up 10 times, and you're comparing that increment to that's not, you want to compare to the line, you pulled up, correct.
That's what I have.
It should last long. I think I've had this 2 years and still like.
We'll see what, you know, we'll see what we do. Yeah, so that. Oh, then here, so you're comparing those to actual integers.
how do I run that command for you?
They should be.
So just on the command line, like don't you just ./lab8? You just ./lab8 space teacher space 10 space.
I'm sorry.
That's how you have the command line arguments into the program.
So I just A dot out, like I'm running.
So you can update all that.
Space, yeah, and
That's
then
the
dump it in.
Yeah.
I'm gonna close the treat as one
So
argument.
your S is a string.
Yeah.
Yeah, I would say like, use it for a variable. You can't variable matches what it's looking for.
Put one.
Or just put the variable.
That's one. Oh,
That's it.
But it, it's just really something.
It's like. Dude, I totally ignored that. It's like, yeah, we were just both looking at it. That's how it be though. It's always like.
Well.
So I did need this if so. Oh.
We just want to be.
But I did that on air.
Oh, so you're.
We're back and you're doing all this stuff.
Yeah. And then. Oh, no.
It's so naive.
You're fine.
Oh, I got one here.
Oh, wait.
I have to, so you just have to do it on that too. Yeah, there it goes. I feel like it's a connection error. Cause it, you know, like on the downstairs in the library had some crappy connection. It was doing it non-stop.
I stopped working on lines sometimes on the computer because I just kept on doing that. Even
I
at
haven't had
home.
it to me at all today.
Even at home, I use my home Wi-Fi to do that.
Yeah.
Be grateful for us. This is just a few cats. Be grateful. You can't have
So we're doing 9 today as well?
No, 9 class, still in the station.
every single time I try and type something in the comments, it's just.
Did you try closing the second page? I don't know if that's the not which meaning that this is in here.
It should be up there already.
I just realized it hasn't happened to me at all today. I have second pages.
Oh shit, that should make you think we're
Second pages.
Oh, I'm really stupid.
No, I'm not saying that's any part of it smart.
I'm not.
I personally think it has to do with this yellow bar that generates.
Yeah.
I think as it generates, it is like what's top.
Sometimes in that.
I heard that you didn't
It's
even
pretty
know
hard,
that.
sometimes it's
Yeah,
not.
yeah.
I don't know, like.
Like, that's like a lot
From
From the
Fucking
past.
curly phrase for me.
I just have to notice
Always
it
get
pops
the
up.
top line. That way I know exactly where the block is. I see the if, and then right under the if,
Oh, I see.
or like for the floor, you see how I have like floor, there you go.
Yeah,
block.
just looking at this, it looks more like it just
That's like
determines what I'm working on.
I mean,
that's
that's
what
what
I
I
see.
on our work as of, again, so it doesn't work out in plans, they're all like break all the time, so, and you can't switch.
No, you can't, yeah, you can't do it.
Like, they don't come out as easy.
Eight and one.
Is this square? Is there any problem? I've done basically done really special. Yeah, I thought it was like really like really fast. See how it's like in blocks. So there's the. For me, it helps me determine what scope I'm in.
Right. I mean, it's good. It's just our style. The style here.
Do I get points for it?
It does look good. It's good, but it's good to be able to be agile with your style. Because different people do it different ways.
Have you pushed your content?
What?
On your code, you can push it out. I'm wondering if that might be the dropping shot.
I just closed dual point.
Why not?
Oh,
It doesn't make sense, right?
no, I haven't.
I'm wondering if that's might be the case. It doesn't do it so well. And all of them, you mix down and all that stuff. No.
I'm sorry, yeah.
No, I'm sorry, did you do the mix style? So I'm thinking, does the mix style, is that required?
I mean, if you don't want to lose style points, which is 10%.
I think that's called kudos.
5 points, yeah.
Almost.
You're gonna